We really have an opportunity here at Morgan to share our innovation, to share some very good discoveries coming out of our laboratories in a wider setting. And we want our legislators, we want our friends in the corporate community, we want our alumni, we want policymakers at the federal level to understand that Morgan is just as exciting research enterprise. And our professors take that aspect of our mission quite seriously.
The Mojo Lab is an experiment, actually, that will teach students how to be mobile digital journalists, and they can report using a device that fits into their back pocket. Actually, it was a safety issue that began the Mojo project, and I said, well, what device can they use that will allow them to feel comfortable to go into what might be a strange neighborhood to them, and what will put them at ease in order to ask people questions.
Mojo stands for a new way that media will be presented in the next 10 to 15 years. It's really new. Nowadays, the newspaper is really dying, and mobile journalism will really put a hands-on look onto the way that we present our media.
I think where we go from here is developing a set of standards that can be replicated at every university. I've been on a tour across the country, sharing this project with other colleges, sharing at a national convention of black journalists, and everyone is interested in how to replicate it at their school. So I think the next step for Morgan is to be a model, is to continue its innovation and to share it. It's not about old media where you have the scoop and you keep it to yourself. Everything is collaborative, everything is participatory, and I don't think that this project should be any different.
What I'm presenting is a project that describes one of the applications, if you will, of quantum mechanics. And the application is the detection of explosive materials at safe distances. You have a guy that's like putting something down that looks like a hockey stick, right? And looking for an explosive. The problem is those are very accurate and very sensitive, but the person that's actually doing the scan or looking for the explosive is at risk, because if the explosive goes off when he's looking for it, he or she is looking for it, they would be injured seriously, obviously. Okay. The idea now is that we can use lasers, and so that the operators of these detectors are at safe standoff distances. You know, you're wondering, can you get all these lasers together? Can you get the oscillator? Can you get the pulse stretcher, the regenerative amplifier? You can get all that stuff to work at the right time. In fact, can you get it to work well enough that you can conceive of how it might work in a system with a 19 or 20-year-old at a checkpoint in Iraq that's pointing it at somebody that's 100 yards away? Is he going to be able to detect that with enough confidence that he can say, that's a threat there, or that's not a threat? That's what a problem is.
This project is about building new highways. As you know that the gasoline being so expensive, and there is a lot of cost to the driver to drive from one point to the other. Then also there are a lot of accidents on the highways. So we built a model. It's a computer simulation and optimization model that allows the designers and planners, in highway agencies, to look at different alternatives before they can finalize on a single alternative.
To design a highway which is fuel efficient, this will be important economically.
This is something that we developed with funding from the Maryland State Highway Administration and also funding from the National Science Foundation, and it has taken us nearly 7 years, and it's a product that we believe we in the whole world we lead in this technology.
While working on getting my master's, I plan on pursuing different innovations on how to improve the roadway, especially here in the state of Maryland, since that they are moving towards greener highways.
There are so many complexities. You have to look for environmental compliance. You have to look at not people's houses being taken away. You have to, obviously, from the agency's perspective, you have to build a highway that is not so expensive. You have to worry about bridges, tunnels, and so forth. So, prior to our approach, there has not been a single unified approach that can tie all these factors together and yet come up with a single computer model which can put everything at one place and let the user who is playing with the software play with different alternatives.
If new highway constructed, then we have to think about how much this alignment affect the environmentally sensitive area, some kind of wetland, some kind of like the wildlife refuge. But in the future, we also have to think about the noise cost and also kind of water pollution impact, air pollution impact.
That's where the future is in the highway design world. We want to build a greener highway. We want to increase the life cycle of highways so that highways are going to be we can get more out of the highways with less maintenance and repair cost. So those are our next steps.
When I think about innovation, I'm thinking about looking at things differently. What we're looking at is the Chesapeake Bay and the health of the Chesapeake Bay. And how are we going to clean that up? When you think about the cost, some estimates have been as high, or low estimates have been as high as $25 billion. We don't have that in the public office. You're not going to tax up $25 billion worth of money, so where is that money? We said, we took a Willie Sutton approach. Willie Sutton was a gentleman bank robber back in the 50s. When I asked him, why do you rob banks? He famously said, because that's where the money is. We said, well, that's what we need to go, is where is the money? And the money is in the marketplace. So how can we use market-based solutions to help environmental challenges? And that's what we're looking at in a different way. The first project that we looked at was oysters. Now, oysters have both an ecological and an economic value to the bay. And we looked at it and said, well, how do we get more oysters into the water? When you think about it, all you're doing is putting organisms in a habitat, which is what you do with corn or soybeans. But there is no friends of the soybeans, no one's trying to save the corn. And that's because business entities are putting those organisms in the water. So we said, how can we get business entities to put more oysters out there? And that's aquaculture. We want to make sure that when we do aquaculture, we do it in a way that protects the coastal communities. So we looked at the watermen and said, how can we help the watermen go from becoming fishermen to becoming aquaculturists? And as we set up our program, we provide them with the oysters and the shells and the seed. They put it in the water, they grow it, they come back, they sell it. Now they have the money to have a sustainable market where they plant oysters, sell the product, and in the meantime, oysters are being put in the water, and that's doing better for the bay. It's an important aspect of what we do to say not just that here's the research that we do and it can help, but here's the research that we can do and it is being used to help.
What you see here, this is all about computer science. This is reality, the real robot, and what you see here, this is simulation of this robot. Here we have environment of one apartment, that's generally speaking the kitchen. In the kitchen we have a robot, and now the colleague using a driver can move this robot.
It has a camera, and when it moves around we can take pictures or images and analyze that kind of information. It can be used in face detection when you do image processing. If we have the robot driving around, it can take pictures of the people that are around, and so we can use software and process that kind of information, face detection, and things like that.
This is just the beginning, and this is just a preview of the things that we're involved in. Our research is growing. The student body, as far as the graduate students, are growing, and the future is very bright.
This is computer science, because when you have image, that's image processing. When you have, for example, communication, this is networking. When you have networking, it's a wireless networking. You have a problem of security. In this case, that robot is computer science.
We have more exposure for our students to get involved in research projects and what's going on today with a view towards what is going to be happening tomorrow. And when tomorrow comes, we want to be still in a position where we're leading the way.
When you put those things together, research that is about engaging young people in the educational process and making sure that they are connected to that research enterprise and they are going to emerge from Morgan with a world-class education. With the research, on the other hand, that's about solving the real problems in the city and in the state, you have an award-winning combination.